Welcome to lesson 2.1. Today, you're going to apply measures of central tendencies to data sets. So, three measures of central tendency are mode, median, and mean. The mode is the value that occurs most frequently in a data set. So if we were going to find the mode of the data set to the right, the mode would be 6 because it occurs 3 times and no other data value occurs 3 or more times. In the next example, 6 occurs twice and so does 7. So the modes are 6 and 7. And then here we have an example where all of the data values occur only once, and so there's no mode for this data. The median is the central value of an ordered distribution. So to find the median of raw data, order the data from smallest to largest. Remember stem and leaf plots? They do that for us. That's why they're really helpful. For an odd number of values, pick the middle value. But what about even numbers where if you count into the middle, you get 2? Then you just calculate the mean of the 2 middle values. So we're going to find the median for this first example, 5271432. First, we put everything in order, and then we count into the middle, so the median is 3. So if we do the same thing with the second data set, we're going to end up with 12, 22, 31, 43, 50, 57. Well, if we count in, the median is halfway between 31 and 43, and so we take the average or mean of 31 and 43, and we get 37. For a large data set, then the position of the middle value is going to be n plus 1 over 2, and that will help you find the median. The mean of a collection of data is found by adding up all the entries and dividing by the number of entries. This is how, say, we get your quiz average. We add up all the quiz grades and divide by the number of quizzes. Boom, you have a quiz average. So here's a numerical example for the data set to the right of the instructions to find the mean. We would add up all the data values. There are 8 data values, so we divide by 8. And so we get 37 divided by 8, which is 4.625, which if you're going to round, you can round to 1 degree more accurate than the actual observations. So you wouldn't want to round all the way to 5 here because the mean is a theoretical value and it can be more accurate than the original data. So to demonstrate that, if there's rounding, we round to 1 more degree of accuracy. All right, so just a little notation. This Greek symbol here is capital sigma, and it means sum the following. Okay, it's a Greek letter, it's the capital of sigma. Later we'll talk about baby sigma. Okay, so there are a couple of notations. For the sample mean, it is x bar, and for the population mean, it's mu. Okay, so not moo like a cow, mu. All right. If the data represents a sample, then we use lowercase n to represent the number of entries, okay, the number of values in our sample. If it's the whole population, then we use capital N. All right, so our formula is to find the sample mean, x bar. You just add up all the values in the sample, and then you divide by baby n, little n, the number of entries. For mu, it's basically the same thing. You're going to add up all the values in the population, and then you're going to divide by the number of entries, which would be capital N. Okay, so some measures are resistant and some are not. So a measure that is not influenced by extremely high or low values is considered resistant. Since we are trying to get a measure of the center of the data, there are many times that we want a value that's not that is resistant, that's not influenced by the extreme high or low values, because an extremely high or low value can really move that a non-resistant measure away from the true center. So the mean is going to be the less resistant of our two options that we frequently use for center. It can be made arbitrarily large by increasing the size of one value. It can also be made arbitrarily small by decreasing the size of one value. That's why making a 0 when your grades are going to be averaged is so devastating to your average. Okay, so the median is not going to be influenced. In fact, if you're just replacing the largest value with an even bigger value, that's not going to change the middle value. So the median stays the same. Again, with the lowest value, it doesn't matter if we have a 50 or a 0, the median won't change. The mean will change considerably. All right, so I do want you to do some practice. So here's a little problem to try on your own. You've got a data set there, 357179731. Find the mean, find the median, find the mode. If you have any questions, please come by my classroom and see me, or at least shoot me an email. I always want to be available to you to answer any questions that you have. Thank you for watching the video. I will see you in class. I hope you have a great day.